I'm sorry, I totally forgot to record this, but I hope the lecture notes is reasonable. You can follow. Okay, if not, then take a look on your beginning algebra or intermediate algebra lecture video. Okay, regarding language. I totally forgot to record this. Totally. And please, in future, those who attend the class, please remind me. Okay. The slope will be y2 minus y1 over x2 minus x1. Now, let me multiply by the LCD, the top and the bottom, to simplify. That will give me, on the top left, that's, can you help me? What is the top left? Eight divided by 4 is 2 times -1, it's -2, minus 6 over 10 minus 7. So that's -8 over 3. That's the slope. But the question in the book only asking find the slope. Okay. Now I go on with find the equation. As for the equation, we know it must be y equals to -8 over 3x plus constant b. Now I plug in one of the coordinates. I think I will plug in the first one, 7 over 8, 3 over 4. So I get 3 over 4 for the y, minus 8 over 3 times, -8 over 3 times 7 eighths, plus b. So 3/4 equals to -7 over 3. I cross cancel the 8. And then 3/4 plus 7/3 equals to b. Do the LCD. So b is 37 over 12. So the equation of the line is -8 over 3x plus 37 over 12. Okay, that's for number 38. Number 50. They tell us to graph it. I will not graph it. I will just get the equation. Number 50. Find the line whose slope is -1/2 and contain -1, -6. So because the slope is 1/2, y equals to -1/2. Y equals to -1/2 x plus constant. Now then, I plug in coordinates -1, -6. So -12 over 2 minus 1/2 equals to b. -13 over 2 equals to b. So the equation of the line is -1/2 x minus 13 over. Now from here, if you want to do the textbook questions, find the 3 additional points. You can just plug in x equals something to get the y's. Okay. Now next part is about parallel and perpendicular notes. Line 1 is parallel to line 2 if and only if the slopes are the same, yet the y-intercepts are different. If the slopes and the y-intercepts are the same, then those two lines are exactly the same line. Maybe I write it as a notes of notes. If m1 equals to m2, and then b1 equals to b2, then those two lines not parallel, but they are equal to each other. Okay, parallel means they don't have any common points. Okay, they don't have any common points. They're parallel, right? The only way they are parallel is they have the same slope, but don't forget, they should not have any common point. Okay, now, by the way, if two lines have different slopes, if two lines have different slope, just a little bit different, then it will eventually meet. Okay, so that's the second note. The second note, line 1 intersect line 2, not an empty set, if and only if line 1, I'm sorry, the slope of line 1 is not equal to the slope of line 2. Maybe to be more precise, equals to a point. Okay, now that's most of the case that we have most of the time. However, the third one, important one, line 1 is perpendicular to line 2 if and only if the product of the slope m1 times m2 is -1. Or another way to say it, slope of one line is negative reciprocal of the other line, the slope of the other line. Okay. Example number 80. We have line 1, y equals to 4x minus 1. Line 2, y equals to 4x plus 7. They have the same slope. Already in slope intercept point, right? Yet the constant are different. So what do we say about line 1 and line 2? Same slope, different y-intercept, they are parallel. Number 82, line 1 is negative 4 over 5x minus 5. Line 2, y equals to 5 over 4x plus 1. Notice that the slopes are negative reciprocals. They are opposite signs and reciprocal. Do we need to look at the y-intercept, Thomas? No, no need. Once the slopes are negative reciprocal, then those two lines are perpendicular. They form 90 degrees. Maybe one more example before I move on to the other topic. For example, let line 1 be 2x minus 3y equals to 7. And line 2 parallel to line 1, line 2 contains 5,3. solution. And the question is find line 2. Find the equation of line 2. Solution. Traditional way. Method 1, traditional way. The way you did it in algebra class. And very likely, I expect in your test, you will do it this way. But I will show you the second method later on. People with more understanding will be able to do that. The traditional way, basically you take line 1 and you change that into slope-intercept form so that you can read the slope. The slope of line 1 is 2/3. Now then, line 2, the slope must be, because it's parallel, right? It's parallel, so the line 2 have the slope, the same slope. And therefore, the equation must be 2/3x plus constant. Then you plug in the coordinates, 5/3. That's 2/3 times 5 plus b. That's 10/3 plus b. That's 9/3 minus 10/3 equals to b. That's -1/3 equals b. So line 2 is given by y equals to 2/3x minus 1/3. That's what we usually do, right? Now the thing is, there's a unwritten, there's a convention that if the original equation is given to us in standard form, then your solution should also be in standard form. Okay, because this is in standard form, not slope-intercept form, then your solution should also be in standard form. That's a convention. That's a convention. Will you mark us wrong, Thomas, if I just go on up to here? I penalize you a little bit. It's not that you did it wrong. It's not that you did it wrong, but I penalize you a little bit. Okay. Now, what we need to do is just massage that. Multiply both sides by 3, so I get 3y equals to 2x minus 1, right? Okay. Subtract by 2x. Now, standard form has a rule that the leading coefficient, the coefficient of x, should be positive. Should be positive. Now, how to make it positive? Multiply by -1. So I get 2x minus 3y equals to positive 1. That's the answer. Thomas, you make us work so hard. No. I'm not trying to make you work hard. If making you work hard make you learn, so be it. Right? But this is not even that case. Okay, this is not even that case. I want to show you something very important, that is the following. What is the equation of line 1? Just for comparison. The equation of line 1 is 2x minus 3y equals 7. Is it right? Now what I want you to do is to compare. Notice that if two lines are parallel, the slope must be the same. In standard form, the variable terms must be the same. The only difference must be the constant part. That's the only difference. So what, Thomas? So the following. That leads us to the second method. A second method that based on more understanding. Okay, line 1 is given by 2x minus 3y equals to 7. Now line 2 is parallel to line 1. So line 2 must have the same pattern, 2x minus 3y equals to constant. Then how to find the constant? We plug the number in. Plug 5, 3 in. 2 times 5 minus 3 times 3 equals to constant. 10 minus 9 equals to constant, that's 1. So line 2 is given by 2x minus 3y equals to 1. Bang. Done. See, you worked so hard, right? You worked so hard earlier. Now, I worked much less. In fact, I believe some people can skip this step. Like, okay? So you will be so tempted to skip here and there, and it will make my work even shorter. Do you think so? Okay, so which method you want us to use, Thomas, in the test? Either one is okay. Either one is okay. Yeah, you want to work hard and long, go with that. Okay, but don't blame me if later on you don't have enough time. Or if you like to do it fast and short, just don't make mistake, of course, in either way. Now, can we say the same thing, Thomas, with two lines that are parallel? For example, maybe I make it more general. Let's say line 1 is ax plus by equals to constant 1. What will the pattern for line 3 that is perpendicular to line 1? Line 1 has ax plus by equals to c1. Let's try to find the slope. So the slope of line 1 is negative a over b. Now line 3 perpendicular to line 1 means line 3 have the slope opposite sign, and you flip it. Line 3 will be y equals to b over a x plus some constant multiplied by a. Call that another constant now. Subtract by bx. But we don't like coefficient of x to be positive, then I multiply by negative 1. So if I compare that, line 1, ax plus by equals constant, and line 3, which is perpendicular, I get bx minus ay equals to another constant. Notice that I swap the coefficient. Coefficient of x becomes coefficient of y. Coefficient of y becomes coefficient of x. And then you change the sign in between. You swap the coefficients, change one of the sign. So suppose let line 1 be 4x minus 5y equals to 17. Line 3 perpendicular to line 1. Line 3 contains 2, negative 3. Then we see line 3 must have this pattern. Negative 5x minus 4y equals to constant. Actually, I swapped the coefficients and I changed the sign. Now then, I need to find the constant. What's the constant with plugging numbers? 5 times 2 plus 4 times 3 equals to C. 10 minus 12 equals to C. C is, so line 3 is 5x plus 4y equals negative. Okay. Suggested homework from here. From this 2.1, I would like you to do from number 17 to number 95. Do every other odd. Don't do all odd. Don't waste your time. Okay. Every other odd is good enough. Okay. Even though this will not be in your test one, but finding equation of a line, finding the slope of a line will be in your test one. So maybe you want to do some from here. Okay, that's for 2.1. Let's go on to 2.2. We talk about functions. 2.2, we talked about functions. Some important stuff to work on here. Things that we will do. First one is definition. And then ways to represent function. And then function notation. And then domain of a function. And then the hard one is, I don't think I can finish this part, difference quotient. I will save this to next Tuesday. Oh, by the way, this Thursday you will have a test. Don't forget. Okay, this Thursday we will have a test. And I will still run my office hour from 10 o'clock to almost 11, but then 11 o'clock I will post your test. Okay, I will post your test at 11, and then you will have 2 hours plus something to do, plus a couple minutes to turn it in. Okay, first one here, definition. A function, you have seen this many times in algebra 1 and in algebra 2, but let's Define it again. Is a relation. Sometimes we also call that correspondence. From one set, which we call domain, to another set, which we call range, such that each element in the domain corresponds to exactly one element in the range. Okay, now that's what the function is. Methods to represent a function. There are methods, ways to represent a function. Our textbook actually say first verbally. This is from our textbook. Second, numerically. And then graphically. You can just read the textbook for this. And then the fourth one, algebraically. Okay. Now, but I prefer to say it this way. The three methods to represent a function. Okay, four methods. The first one, so the following is Thomas' version. The first one is by mapping. Okay, what is mapping? Mapping, you draw two ellipses. Now the ellipse on the left-hand side is your domain. The ellipse on the right-hand side is your range. And then the element in the domain corresponds to, each element in the domain corresponds to exactly one element in the range. So let's say you have this situation. This is what we call mapping. Let's say this is A, B, C, D, and this is 1, 2, 3. Now you see every element in the domain, corresponds to exactly one element in the range. So you will see that for every element in the domain, it will only have one branch coming out. Only one branch coming out. Only one arc coming out from there. Now, once you have extra arc coming out from the element in the domain, like this, for example, you see D goes to 1 and also goes to 3. Now, then it is not a function anymore. Okay, that's not a function anymore. Second method. Second method is by table. So you can create a table. This is the one in your domain. Sometimes we call that the X, and this is the range. A corresponds to 1. B corresponds to 3. C corresponds to 2. D corresponds to 3. But Thomas, I don't think this is a function because you see the 3 actually comes from D and D. No, 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 no. No, 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 no. No. The definition of function says only element in the domain cannot branch. It has to go to only one element in the range. The definition of function did not say, the definition of function does not say that the range can only come from one element in the domain. It doesn't say so. So element in the range may correspond to as many elements in the domain if possible. Okay, the one that cannot range is the domain. Okay, now the third method is coordinate method. Coordinate method, you write it as a coordinate where the x component is the element in the domain, and the y component is the element in the range it corresponds to. So A goes to 1, B goes to 3, C goes to 2, D goes to 3. Okay. Okay. The last one by graphing. The last one by graphing, where the domain will be on the x-axis and the range will be the y-axis. So let's say this is my A, B, C, D. A goes to 1, B goes to 3, C goes to 2, D goes to 3. Okay. That's what the graph looks like. Now, because of this issue, we may have a situation we need to check if an equation is a function of x. So next big question is if we are given by an equation, how do we know that the equation how do you know the equation represent y as a function of x? The abstract solution, keep in mind, ask yourself, is there find if find if there is any x corresponding to two different y's. If so, then it's not a function. Otherwise, so if you think, oh, you know what, I cannot find any x correspond to two different y's, then try to solve for y. For example, I do question from the book, number 20. We have x squared minus y squared equals to 16. Now, is that y is, can we say y is a function of x in this equation? Now, what you need to do is, can you find an x that gives you two different y's? Can you find one x that gives you two different y's? An x that gives you two different y's. I can show you this, for example. Okay, when x equals to, let's say, square root of 17. So x squared equals to 17, right? Okay. If your y is 1, then y squared equals to 1. Therefore, 17 minus 1 equals to 16, right? Now, the thing is, if you replace your y by -1, it will work the same way. You see, so square root of 17, comma 1 satisfy that in that equation. However, square root of 17, comma -1 also satisfy that equation. But the thing is, if you kind of imagine the mapping, it means square root of 17 corresponds to 1 and -1, right? So it is not a function. Okay, so to show that y is not a function of x, all you need is to find one x that gives you two different y's. That's actually all you need. That's what we call technique of contradiction. Show the contradiction. Okay, so if somebody say, I'm not married yet, for example, how to show that person is wrong? Show the spouse, right? Okay, you say you're not married, but your wife is here, right? Okay, now of course, there's another method. This other method is more into the second method. What is that second method? Try to solve for y. The second method, you try to solve for y. So negative y squared equals to 16 minus x squared. Y squared equals to x squared minus 16. I refers to the order of subtraction. But then when I apply the square root, I solve for y, I am forced to use square root here. Okay, I'm forced to have plus minus there. So there are x's with two different y's. Okay, so y is not a function of x. Okay, just think of, can I find an x with two different y's? Okay, that's for the ways to represent a function. Next, function notation. Once y is a function of x, we can write y to be fx. This is not f times x, but this means y is a function of x. For example, fx equals to 2x minus 1. That's a linear function. Okay. Or we can also write using other symbol. We write phi parenthesis r equals to 4 over 3 pi r cubed, for example. Now this means phi is a function of r. Or ht equals to t squared minus 2t. So in this case, h is a function of t. For every t you plug in, you will have only one value for the y's, for the f, for the phi, for the h. Okay, suppose I say, what is f negative 3? F negative 3 means I replace the x by negative 3 and then compute from there. How about phi 3? It means I replace the r, which was the variable, the independent variable, by 3. So this will be 4 over 3 pi times 3 cubed. That's 4 over 3 pi times 27. Cancel 27 by 3, that's 9 times 4, that's 36. How about H7, which means I replace the T by 7. Now from here, let's see more abstract one. How about f of x minus 3, for example? If I replace the x by x minus 3, so fx is 2x minus 1. F blah is 2 blah minus 1. F blah is 2 blah minus 1. Okay, suppose I have phi x instead of r. If phi r is 4/3 pi r cubed, then phi x will be, I basically replace the r by x. And that's the simplest we can go. How about ht? Instead of ht, I make it t plus x. H blah is blah squared minus 2 blah. So h blah is blah squared minus 2 blah. And then from there, I simplify t squared plus 2tx plus x squared minus 2t minus 2x. I know that's nasty, but it is what it is. Okay, now finally, something called, I'm not done with this section. I'm not done with this section. I will still need to talk about the domain. Okay, so, but let me do more problems, something called piecewise defined function. Piecewise defined function. Not too hard. This is not hard at all. I am preparing you once we come back from the test. So on Tuesday later on, then we can do a lot more about functions. Algebra is about functions. Piecewise defined function is a function defined piece by piece. Let's say, for example, we do number 50. Maybe number 52 rather. Let me do number 50. Yeah, I have 3 minutes left. And I have, that's all I need. 52 fx is equal to 4 minus 5x when x is less than equals to negative 2 equals to 0 when x between negative 2 and 2 x squared plus 1 when x greater equals to 2. Now, what I meant by piecewise defined function is a function defined piece by piece is the following. Imagine this number line here. Okay. Now the first piece, anything less than or equals to -2. Anything less than equals to -2, use that function. So the function that uh, being used for this section here is 4 minus 5x. Now between -2 to +2, from -2 to +2, not including the endpoints in this case, we use this function. And then greater than or equals to 2, we will use this function. So for example, if I need to know what is f part A, what is f -3, you need to first know where is -3 located. -3 located in this section, right? That's where -3 located. So then I need to use 4 minus 5 times -3. You need to know where that x located to know which rule you use. Part B. How about F4? F4. Where's that 4 located? Where's this 4 located? 4 is located here. Okay, so I will use that rule for that region, for that segment. 4 squared plus 1. 16 plus 1, that's 17. Now part C, how about f -1? F -1 is located, I don't know what I should use. -1, this -1 here, located here, approximately. Okay, so use the rule for that region. It's like imagine that this number line are actually different countries in the world. Different countries have their own rule. Okay, so if your value is -3 in the yellow country, you use 4 minus 5x. Okay, if you are -1, then you are in blue country, you will use 0. It's just a constant function. Now from there, we get the coordinate -3, 19, 4, 17, -1, 0. That will help us to do the graphing in 2.3 or later. Okay, suggested homework from here on 2.2b A from number 15. No need. From number 19 to number 51 to the odd ones. Now, I don't expect you to work on this suggested homework within these 2 days. I want you to work on your test. Do very well on your test instead, please. Okay, then after your test, you work, after you're done with your test, then you do the suggested homework. Can the restricted domain be interval notation too? The restricted domain, yes, yeah. But that's something we will learn when we come back from the test. The restricted domain in interval notation. That's actually the later part. Right after this, right, still in 2.2, part B, we will learn how to find the domain of a function. Okay. Yeah, see you then on Thursday. Again, I will have my office out from 10 o'clock until almost 11, but then I will post the test at 11 o'clock. Okay, see you then. Bye-bye.